All right, so let's try the first example. You're given a table of numbers or a table of data. And the question is, if you look there at your notes, determine if each one of these tables is a function. So what you need to realize is, just because I give you a table and you have x values and y values, that doesn't necessarily mean it's a function, okay? The way that you know it's a function is based on what you should have written down in the previous video, how to determine a function. Only one y value can be matched with an x value, okay? So your x values pretty much cannot double up to give me two different y values. Or my input, if I have the same input number, I shouldn't get two different output numbers. Now, there's another way for me to explain this, and we'll probably go over it in class. I'm not going to put it on the video, but there's another kind of analogy that I'm going to give you in class, because if this isn't clicking, I'm pretty sure what I'll tell you in class will. So just kind of get through the notes, and somebody just remind me when we come into class, and I ask for your notes and all that kind of stuff, and we're getting ready to do the homework and the mastery chat. Just remind me, and I'll tell you an easy way to remember whether a table is a function or not. So let's look at our first table here, and you want to start with your independent variables. And I just told you in the previous video, your independent variables will always be your x values. So remembering what I said about the x's, if you have the same input, you cannot have two different outputs. Hopefully you're looking at this table and you see that I have two values here for one x. Okay, so I have two input values that are the same. The value is 1, but this output gives me a -3 and this output gives me a +3. That can't happen. That's just based on the definition. If I have an x value of 1, then whenever I get an output, it should be the same number, okay? And in this case, I don't. So if I was to ask you, does this table represent a function, you would just simply say no, okay? So there's not a lot of wiggle room for this. You either know how to identify a function or you don't. See what I'm saying? Now, let's look at the next one. I think this table is the one to your left, or to your right, or what is on the side of your notes. So again, if we start with the x values, you see that we're doubling up. You got 2 zeros, 2 3s, and a 5. All right? But notice the difference between this table and our first table. Or is there a difference between this table and our first? Well, first of all, we got more doubling up, so that's fine. If I have the x value as for 0, the first two, does it give me the same y? And hopefully you're saying no, because 1 0 gives me a +2 and the other gives me a -2. And at that case, you don't even have to go any further in your table. If you get one mismatch, you're done. You can't say, well, this one works and that one. No, these two values, the input is the same. It's giving me a different output. That can't happen. So for this example, once again, your answer would simply be no, it doesn't. Now, if I ask you why it doesn't, you've got to be able to explain to me what I just said. You've got to be able to say, okay, I got 2 zeros and 2 different numbers, or give me a circle and point, and a frowny face or something. You've got to show me that you understand what the relationship's supposed to look like. Now, this is our last table. We are happy to announce that we have no repeating x values. Every input value is different. That's awesome. But then you look at your y's. Your y's are all the same. But remember, the rule doesn't say that you can't have, the y's can't double up. It's just the x's that can't repeat. The only time the x's can repeat is if the y's are the same. So let's take a step back. Look at this first one. Here's x to be 1 and 1 here. If this was a +3, then I would change that to a yes, because it's the same x value giving me the same y value. All right? But if I have, all different x values and they give me the same y value, that's okay, because I don't have anything doubling up. So I know it looks funky, because you're probably not used to seeing them look like this and like pre-algebra, but this last table is a yes. I have all different different x values. I have nothing repeating and giving me a different output. So like I said, if you're scratching your head and like, I'm not sure if I understand, we will get it straight before you jump into your homework. I'll give you that analogy, and I guarantee you will never forget how to determine if a table is a function again or not. So in the next video, we're going to move on to the function rule. We're going to go away from the tables and go to another